Present invention relates to the textile production and development of amber composite filaments, where technologically processed amber is the main component.
I am Dr. Engineer Inga Lashenko from Riga Technical University. My research work is devoted to elaboration of composite amber fiber. What do we know about the Baltic amber? How is the amber connected with our life? I think the amber is a virgin element that contains the code of evolution.
The goal of invention is to develop a new kind of product, amber composite thread, with optimized, technologically processed amber context. The particles are evenly integrated in thermoplastic polymer matrix. They may have additional components contain thread with a smooth surface that does not cause allergic reactions, blood clots, reflect UV rays, having biocompatibility with living tissue. Amber, organic acids compound with high molecular weight with an average of 79% carbon, 10.5% hydrogen, 10.5% oxygen. Basic structural elements of amber are aromatic and hydroaromatic line compounds with condensed nuclei which contain double associated carbolics, hydraulics and ester group bonds. Amber contains three types of compounds: terpenoids, sequiterpenoids, soluble organic acids, succinic acid and its isomers, insoluble polyethers formed as a result of condensation of soluble acids with alcohol. The choice of amber was optimized to succinite or the Baltic amber due to three criteria. Firstly, conditions of amber fossilization. The Baltic amber is pine tree, Pineus succinifera, fossil resin, mainly of Paleogenic period, formed as a result of polycondensation of resin acids and terpenes. The main fossilization conditions are long-term amber forest oxidization in soil, further redeposition with burial in coastal areas, in lagoons and delta sediment with weakly oxidizing alkaline environment. Those were fossilization conditions which influence diagenesis process, characteristics with oxygen containing compounds including free succinic acid and ether formation in succinite. Compared to other types of amber and amber-like resins, succinite contains the highest amount of succinic acid, 3% to 8%, which is the determining factor to select succinite as the key component developing the amber composite threads. Based on scientific research work analysis, it is established that succinite inherent positive features to human body are determined by a few factors: free electron energy impact, succinic acid presence in amber, good absorption capacity of ground succinite, and the ability to bind the free radicals produced in the human body and human skin. Secondly, its chemical composition that is not stoichiometric. Apart from other types of amber, succinite contains up to 12 chemical elements. The Baltic amber does not contain salt or heavy metal to make it possible to use it for medical and cosmetic application. Thirdly, the presence of other minerals. The Baltic amber may contain negligible quantities of sulfur, between 0 and 0.32%, and ashes up to 0.2%. This enables us to declare the relative purity of the Baltic amber. The method of obtaining amber composite threads containing technologically processed amber means it is a long process. What is the first step? Succinite is purified by the two-step flotation method. In pure water and salted water, the succinite granules eluted. Then the granule drying is carried out at a temperature of 105 degrees for 10 minutes. Then the next step, succinate granules are purified from the mineral crystals and grained by a two-step micronization method in argon gas environment at a temperature of plus 20 degrees centigrade. With a processing speed of 150 to 250 RPM during a 10-minute process. Succinate microparticles are screened where inorganic impurities in particles are up to 3%. Succinate fine grinding is performed in distilled water up to 3 micrometers. The resulting suspension is to be dried. It shows a histogram of the distribution of the percentage of particles of amber. Infrared spectroscopy helps to determine changes taking place in succinite when being technologically processed, hence micronized succinite powder was studied. As a result of infrared absorption, bands were identified. Absorption bands in example samples were the same as those of the wave, numbered in range from 4,000 cm to 1 and 500 cm to 1, as well as the relative intensity. There is evidence that the fluctuation base groups, which is characteristic to succinate acid and lactone groups, remain virtually unchanged in the technological processing of amber. Technological process of obtaining amber composite thread includes the following steps. Primary granulate PA6 extruding with technologically processed succinite at the extrusion temperatures of plus 235 to 245 degrees centigrade. Secondary extrusion in main extruder to obtain homogenized composition granules. Its lubrication. Stretching. Rewinding to the biocone bobbins. Developed two-step technological manufacturing process enables to receive amber threads with evenly distributed technologically processed succinite and provides the necessary strength characteristics of the thread. A new product type was developed, amber composite threads, with a significant advantage compared to other known polymer composite threads. Composite threads with a smooth surface that does not cause allergic reactions, stimulates the activity of the skin, promotes normal skin area regeneration, reflects ultraviolet rays, prevents the formation of clots in contact with platelets, which have been biocompatibility with living tissue. In addition, technologically processed succinite activity lasted longer than 1 year. Developed amber composite threads are designed to expand textile assortment, and they can also be used as a preventative material in cases where skin changes occur, including skin condition improvement for diabetics and textile products for surgical purposes.